This is 6.1, factoring polynomials. So when we're talking about factoring, it's the reverse of multiplying. So you write an equivalent expression as a product of two or more expressions. So back in chapter 5, we learned how to use the box and multiply. Now we're going to turn it around and go backwards. So first let's do some simple factoring. We've got monomials. So we have 20x to the second power. We have multiple ways we can factor this. This could be 4x times 5x. That would give me 20x squared. It could also be 20 times x squared. Could be 20x times x. Might be negative 4x times negative 5x. There's multiple and quite a few possibilities. 2x times 10x. Negative 2 times 10x, negative 10x squared. So anything that when it multiplies together gives me 20x squared. So now let's look at the next one. I'm going to give you a second to think up ones that you can think of for 8x to the fourth power. If you need to pause, pause. If not, coming up with some of those ideas. They multiply together to give you 8x to the fourth. So it might be 4x squared and 2x squared. It could be x squared times 8x squared. It might be 2x to the third times 4x. Could be negative 8 times x to the fourth. Could be negative 2x squared times negative 4x squared. So there's a lot of possibilities. The next one, go ahead and pause it again and see if you can come up with a couple on your own. Okay, now that you're back, let's think about that. As long as your answers multiply together to make 6m to the fifth power, they should be correct. So 6 times m to the fifth, 3m to the second times 2m to the third, negative 2m squared times negative 3m to the third, m times 2m to the fourth. So you see that there's lots of possibilities. Let's do another one, our last one. So go ahead and pause and see if you can come up with your own. Okay, hopefully you did pause and try on your own first. So any combination that gives me 12a squared b squared. So I'm going to do 3ab times 4ab. 3 times 4 is 12, a times a squared, b times b squared. I could do 3a squared times 4b squared. So we can also do 12 times a squared, b squared. Negative a squared times negative 12b squared. As long as when I multiply them together, I get 12a squared, b squared. So taking that factoring of monomials, all that was kind of a warm-up of how we factor, what numbers can be multiplied together and what happens when they do. Now what we use the majority of our ability to factor with is problems like we're going to do right now, or we get a little further in the chapter. You won't see a lot of the ones we just did, but it just was kind of that warm-up of, okay, that's what multiplies together. When you look to factor, you look at both of the terms in this problem, and you say, what can I take out of both? And I'm talking about dividing. What can I divide the 5 by, and what can I divide the 15 by? Or pardon me, what can I divide the 5x by, and what can I divide the 15 by? So in this case, it happens to be 5. This is 5 times x, and this is 5 times 3. Now, I want to see all these steps when you do your assignments, and I'll show you a couple of things that help me when I'm doing factoring to kind of help me see what I'm doing, and hopefully it'll help you as well. So now, I know I have the 5s. I'm going to take the 5 out. I cross them off. And everything that's left, other than some of the parentheses, are going to come right down. So this is an x plus 3. So you're factoring, again, taking what's similar out. Let's try another one. What do they have in common? They both have 3. This one is 3 times x squared. This one is 3 times 1. And it's very important you do the step, because I see all the time people skipping this step and then they miss something like this. So we take the 3 out and we're left with x squared plus 1. Okay, another problem like that one. Again, I look at it and say, what can I take out? And you want to take the most out you can. So now you should notice that there's a y in both terms. Remember, your terms are separated by a plus or a minus. So this is a term and this is a term. They both have y's. This one has 4 y's, but this one has 3 y's. So if one has 4 and one has 3, I know I can take at least 3 y's out, because this one has 3 and this one has more than 3. Then I look at the number 5 and 20. I can divide by 5. So here I can take 5y to the third out. I'm left with y to the first power. 5, y to the third, y to the first. Remember, when there's 2 bases with 2 exponents, we add the exponents. Here we want 5y to the third to come out. 5 times 4 gives me 20, and I needed y to the third. So I take 5y to the third out, and again, cross it out. I'm left with y to the first, which we don't usually write the 1, minus 4. Let's try another one. This is another one that's a little bit more involved. Again, looking for the largest number and the largest amount of letters we can take out. So this problem, I can divide both of them by 4. So I know I'm going to get a 4 out of both of the numbers. Both of them have a squared. So I'm going to take the a squared out as well. So for this term, 4 times 4 equals 16. We already have a squared, and all that's left then is b squared plus 4a squared. Now these should be exactly the same. You should be seeing that every time. These have to be the same. 4 times 5 gives me 20. A squared we already got. So we take out the 4a squared, and what do we have left? 4b squared plus 5. All right, let's do one more problem like that. We're looking at this problem, and again, this one has 3 terms, so it needs to be what can I take out of all 3. Looks like if I'm just looking at the numbers, I can take out a 3. 12 is 3 times 4, 3 is 3 times 1, and 6 is 3 times 2. They all have m's and n's. Looks like, let's see, 2 n's, 2 n's, 4 n's. If I take 2 n's out, they all have at least 2 n's, and they all have at least, at least 2 m's. So let's take that out. 3 m squared n squared. And again, you want it to be the same, and you want it to be the most you can take out. So 3 times 4 gives me 12. I needed 4 m's. I only have 2, so I need 2 more. I needed 4 n's. I only have 2, so I need 2 more. Plus, because there's a plus right there, 3m squared n squared. Now we look again, 3 times 1, okay? We need 3 m's. We only have 2, so we need 1 more. We have 2 n's, and we needed 2 n's, so all we needed there was the m. If I multiply these together, I'm going to get this. Plus 3m squared n squared. 3 times 2 equals that 6. I need 2 m's, got them. 2 n's, got them. So that's the only piece I'm missing. Copy down the part that's the same for all parts, and I'm left with 4m squared n squared plus m plus 2.